Hello everyone, my name is Abhishek and welcome back to my channel. I'm sure you must have watched a lot of videos on Apache Kafka and how it helps with data streaming. But today's video is going to be totally different. In this video, I will talk about common challenges with Apache Kafka when companies use it at scale. This video is going to be quite informative because I will talk about serious issues like data quality concerns with Apache Kafka due to lack of schema validation. I'll also show you through a demonstration why and how it is important. At the same time, I will also talk about storage costs and internetworking costs with Apache Kafka when you use it as a cluster. Make sure you watch this video till the end because I'll not only talk about issues, but I'll also tell you how to address these issues using a drop-in replacement for Apache Kafka, that is Buffstream. To be honest, making such videos takes a lot of time and effort, and these videos need sponsorships. I should thank Buff for believing in our content and sponsoring today's video. Without any delay, let's get started. So, to make it simple, let's take one issue at a time, deep dive into it, understand how Buffstream addresses the issue, and then let's move to the next one. We'll start with the most important one first, that is lack of schema validation, which leads to data quality concerns with Apache Kafka. What does that mean? Let's take a standalone Apache Kafka instance. For example, there is a producer. Producer writes the log messages to a Kafka topic. A Kafka broker stores these messages onto the local disk. If you're on AWS, this can be AWS EBS. Then there is a consumer that reads the messages from the topic. This is the usual workflow. And if you observe this workflow carefully, a Kafka broker merely acts as a data pipe. That means it does not reject the incoming message from the producer, even if the message is in the wrong schema format, or even if the message is a bad message. It can still enter the system, it can be stored onto the disk, and if consumer also does not perform schema validation, it can be read by the consumer. Now you might say, but Abhishek, I can integrate a third-party schema registry service with this workflow. Yes, you can definitely do it, but it is only going to complicate the process. Let me explain how. So if you add a third-party schema registry to this workflow, both the producer and consumer have to perform double the activities. So this time, producer, instead of writing the log message first, producer has to first register the schema with the schema registry. If the schema is already available, producer will fetch the schema ID and synchronize the schema ID with the log message. Typically, schema ID is appended to the message, and this is written to the topic. Again, Kafka broker does not reject the incoming request. It can still hold the message with wrong format, but broker does not reject the message to the topic. And when it comes to the consumer also has to perform multiple activities. First, it has to read the message. Then it has to extract the schema ID that producer has appended to the message. And once the schema ID is extracted, it should get the information of the schema, and then it has to perform desynchronization. Overall, both producer and consumer, they have to perform multiple tasks. So your system is loaded. And even after doing this entire thing, Kafka broker does not restrict the message to enter the system. Still a bad message can enter the system and it can be stored onto the disk. This can be easily avoided if Kafka broker integrates with the schema registry. That is, instead of producer talking to the schema registry, consumer fetching the schema ID and fetching the schema, if Kafka broker can integrate with the schema registry and it can reject the request at the first point if it does not meet the schema requirements, you don't have to do all of these. And that is exactly what Buffstream does. So a Buffstream broker, just like your Kafka broker in this case, it can be integrated with a schema registry. It can be any schema registry. Only thing, it has to implement Confluent schema registry API. Or you can go with Buff schema registry, which is implemented by the parent company Buff. So when producer writes a protobuf message, the protocol buffers is very commonly used in case of Buffstream. So when producer writes a protobuf message, Buffstream broker gets the schema, which is typically .proto, from Buff schema registry or any schema registry and verifies if it is according to the format, schema format. If it is not, the request is rejected at the first place. And if it is according to the schema, then it is added to the object store. Buffstream deals with object stores such as S3 or any S3 compatible. And then consumer reads the message from the topic. So this is how Buffstream broker or Buffstream addresses the challenge. As I told you, I'll also show you this entire thing through a demonstration. Just make sure you watch the video till the end so that I will cover the installation of Buffstream. I will show you how Buffstream broker can use this schema to block the request from the producer if it is not in the right format. Now let's head to the second challenge, storage costs or infrastructure costs. Lot of people assume because Apache Kafka is an open source software, it won't cost them a lot, but it is not true. I'll explain from a production grade Kafka cluster point of view. But before that, if you're not aware how Apache Kafka costing works, let me explain you through a very simple example. This is not a production setup. This is a very basic Kafka setup. As you know, producer writes data to a Kafka topic and Kafka broker stores that data onto the local disk. So imagine if producer writes 1 TB of data, Kafka broker stores that 1 TB of data onto the local disk. If you're on AWS, it is going to be EBS. So you will be charged both for compute that your Kafka server is going to use. Along with that, you will be charged for 1 TB of AWS EBS utilization. Now, this might sound fair enough to you, but wait till I talk about a Kafka cluster costing. Now, because this is a production grade setup, you will not use a single broker, but you will be using 2 brokers or 3 broker cluster. So let's say you have set up 3 broker Kafka cluster, broker 1, broker 2, and broker 3. You have a producer, and considering the production setup and considering all the best practices, producer writes to 3 partitions of a Kafka topic. Let's say partition 1, partition 2, and partition 3. Because there are 3 brokers, let's say each partition or each broker becomes partition leader. So broker 1 becomes the partition leader for partition 1, broker 2 becomes the partition leader for partition 2, and broker 3 becomes the partition leader for partition 3. Again, because this is a production setup, you need to set it up with high availability, make sure there is no data loss. So usually on a production setup, replication factor of 2 or 3 is set up using Apache Kafka. So let's say you have set up a replication factor of 3. That means, what does replication factor of 3 mean? It means whenever your producer writes data onto a partition, if producer writes 1 TB of data onto partition 1, the partition leader, which is broker 1 in this case, it replicates that information onto partition 3 as well as partition 2, because you have set up replication factor of 3. So there should be 3 instances of your data basically. Similarly, when producer writes 1 TB of data to partition 2, the partition leader of partition 2, which is broker 2, replicates that data onto partition 1 as well as partition 3. Similarly for partition 3, right? It replicates onto broker 1 and broker 2. Now this way, if your producer generates 3 TB of data, 1 TB onto each, considering replication factor of 3, overall 9 TB of data is stored onto EBS, right? Each broker has a dedicated EBS instance. So this broker 1, because it has 3 partitions, 3 GB of data, right? 3, 3, 3, which is going to be 9 TB of EBS volume. Now you can imagine how much it is going to cost. As I told you, it is going to cost both for the compute as well as storage. For compute, you will be charged for 3 brokers. And when it comes to storage, you will be charged for 3 multiplied by 3. Now let's try to see how Buffstream overcomes this challenge. So what Buffstream has done, it uses object store for the storage. That means instead of using EBS for the storage, Buffstream uses object store. Something like AWS S3 or Google Cloud Storage, or maybe blob storage on Azure. So if you take AWS as example, what Buffstream does, whenever producer writes, let's say in this case, there is producer which writes 1 TB of data onto partition 1 of a topic, Buffstream stores that information onto the object store. Now, S3 comes with durability and availability unlike EBS. That means you don't have to take care of replication of data. The data is highly available if you store that on AWS S3, Google Cloud Storage, or blob storage. They automatically take care of availability as well as durability. Now, this is something Buffstream has done significantly well to reduce the costing with Kafka. Now, in this case, if producer writes to 3 partitions of the topic, 1 TB, 1 TB, and 1 TB each, it is only going to charge you for 3 TB of data, and that is also not EBS, but it is going to be AWS S3. And you know that S3 is a very cheap solution when you compare that with EBS. So it's a two-way cost reduction. One, you are significantly reducing the amount of data that is stored. Two, you are moving from EBS as a storage solution to S3, which is a quite cheaper one. So this way, if you perform cost calculation, like if you use AWS cost calculator for the scenario that we used, it roughly comes to 8 to 9 times cheaper. And as per Buff documentation, so if you go to their official documentation, you will notice that Buff is 8.4 times cheaper when you compare with Apache Kafka. And even if you do rough calculation on the analysis we performed, it also comes somewhere close to that. To add to it, you might ask, but Abhishek, if the data is stored onto S3, won't there be latency? Definitely, latency is a trade-off. When you perform read-write operations to S3, it might not be that efficient when compared to EBS, but it is not going to be that significant. It is not going to be that significant that you actually see the latency. And also what Buffstream does efficiently is whenever you write data to Buffstream, it transforms the data to Apache Iceberg. So Apache Iceberg is, a popular format where you can easily perform analysis on the data. So instead of storing data directly onto the S3 or object store, Buffstream transforms that data to Apache Iceberg. And Iceberg tables are actually stored on the object store. On top of that, Iceberg metadata is also added. Now, this makes consumers like Apache Spark, Antenna, or Starburst easily to perform analysis on the object store. So this is how it reduces the costing and also it makes easy to perform analytics on the data that is stored. This is about storage or infrastructure costing. Now let's talk about internetworking costing. Let's go back to the same example of a Kafka cluster. So as we discussed on a production grade Kafka cluster, you set up multiple brokers. And for high availability, you actually set these brokers either in different availability zones or in different regions. For example, you set up broker 1 in US East 1A. This may be in 1B, 1C, or altogether in a different region. Reason for doing it is very simple. In case one of the availability zones of AWS goes down, you still have a highly available Kafka cluster. But saying this, an important thing to note, when consumers reads the messages from partition leaders or from partitions, they can only read that from the partition leader. If you have a consumer, let's say in US 1B, it's the nearest region for the consumer, or it's a service in US East 1B. If it reads the information from partition 3, which is in US East 1C, this will incur inter-networking costs. A lot of people might not know this, that when you try to access or when you perform a transaction between different availability zones or between different regions in AWS, that will incur inter-networking costs. So in this case, consumer and partition leader, if they are in different availability zones or regions, that would also cost you. So this is basically called as inter-networking costs. So along with the compute, along with the storage, if you're using Apache Kafka, this is additional cost that you have to bear. Now you might ask, but Abhishek, how Buffstream deals with it? As I told you, Buffstream use object storage. So it does not deal with replication. Object storage itself takes care of high availability. So it maintains data across different availability zones and regions. S3 takes care of the durability and availability of the data. One important thing to mention, Buffstream is independently verified by Jepsen. So Jepsen is the gold standard for distributed systems testing, and Buffstream is the only cloud native Kafka implementation that has been independently tested by Jepsen. I'll also put the link in the description so that you can read the Jepsen report. Now that we have learned a lot about Buffstream, let's try to put that in action. So I'll show you how to install Buffstream, a demo Buffstream instance. Using that, we will try to understand the importance of schema validation. Let's go ahead and look at the demo. So on my local machine, I will start Buffstream broker. Of course, you can use AWS, Azure, or GCP as well, and you can integrate with any object stores. If you want to follow those steps, you can go with Buffstream official documentation. Even for this demo, I will use this documentation to start Buffstream broker on my local machine. I'll put the link in the description so that you can also follow it after watching the video. So first of all, I should download the Buffstream binary and grant it with the required permissions. So I just have to run this command, curl command to download the binary and chmod to grant with the permissions. Once this is done, just run or just execute the binary by passing a parameter serve or an argument called serve. That's it. So we have Buffstream broker running on our local machine. But Abhishek, if I want to explore user interface for it, can I integrate it with AKHQ or Red Panda console? You can definitely do it. Again, those steps are also available in the documentation. Just take a different terminal and execute this Docker command from the official documentation to start Red Panda console for your Buffstream broker. I'll just change the port from 8080 to maybe 8091 because 8080 is already used on my local host. So localhost 8091. Perfect. So I can access the Red Panda console. And from here, I can create the topic, I can create schema registry, consumer groups, typically everything that you can do with Apache Kafka. Great. Now that we have Buffstream broker running, let's set up producer as well as consumer. So we'll head to our first example. That is, let's see how things work now as we learned during the theory part. First, we will not connect the Buffstream broker with a schema registry. So let's see how producer can connect with a schema registry, how it can envelop the information with the schema ID, and how consumer reads that by extracting or unenveloping. So for that, I'll just stop the user interface for now. I'll take two terminals, one for producer and one for consumer. So on the producer terminal, I'll run this go command. But Abhishek, where can I get this demo application from? So you can use again the official buff build GitHub repository. So you have Buffstream demo. You can use this demonstration for the purpose of learning how Buffstream works. You will also find this link in the description. So on one of my terminals, I will run producer. Cool. If you notice, so what I'm trying to do here, this is executing producer. This is the topic, email updated. This is the group, and this is the schema registry, CSR URL. So I'm using a schema registry. Great. It started sending some messages, and you can see here producer produce semantically valid protocol buffer message, and it says produced invalid data. So it is sending combination of messages. On the consumer terminal, so a different terminal, I will start consumer, right? And consumer is also integrated with the CSR URL, Confluent Schema Registry URL. Cool. Now let's see what is the output. After some time, you can clearly see that consumer attempts to unenvelope every message, but it can only do for email updated messages. Like it cannot do for every message because the reason is very simple. Producer has not produced all the messages according to the schema validation. Now you can also try just stop the producer instance. This time, what we will do, we will disconnect producer from the CSR. So I'll again run the producer on the producer terminal. This time you can see I'm not passing any CSR URL. Now when I execute this on the consumer terminal, let's refresh, you will see unknown magic byte. What does this mean? This means no producer has not enveloped any message. It is not even connected to the schema registry, but consumer is trying to unenvelope the messages. So it is trying to extract the schema ID and verify if the message is according to the schema. But it is not able to do that. As I told you, producer is not integrated with the schema registry. Now, this is the problem that Buffstream solves. That is exactly what we learned in the theory part as well. Now, there are complications with producer is connected to the schema registry, producer is not connected to it, or producer has enveloped some of the messages, has not enveloped some of the messages. This can be eliminated. Like I will stop both the producer and consumer executions. This time, what I'm going to do, I will stop the Buffstream broker as well, and I will start the Buffstream broker with a proper schema integration or schema registry integration. For that, we will head to this file called config buffstream.yaml, right? So within this file, so you will notice that the schema, so this is the schema registry, integration is provided in the file. So I will pass this file as an input to the Buffstream serve. Previously, we were only running Buffstream serve, but now I am passing this configuration file, which has information of the schema registry. Perfect. Now let's wait for the Buffstream to start. Great. Let's head to the producer terminal, run producer without any schema registry integration. It's not required because the broker is already connected. And let's also run the go command on the consumer terminal. Now, this time you will notice because you have set up strong schema enforcement at the Buffstream broker, only successful messages at the consumer end. So what exactly happened? Just like before, producer sent unenveloped data, but because of the schema enforcement, consumer only received data that passed schema enforcement. And it is also automatically enveloped. I hope now it is clear what we learned in the theory part. So we learned during the theory part that Buffstream broker can enforce schema validation, and we have seen that in practice. You can also try this out. I'll put all the useful resource links in the description. I'll also add some more where you can learn about Buffstream in depth. Also, you can try out S3 integration to explore cost optimization with Buffstream. If you have any questions, do let me know in the comment section. I'll definitely respond back to your questions. See you all in the next video. Take care. Bye bye.